before we start, I would like to ask about who of you is interested in analytics? Predictive analytics? Sort of, okay. Who knows OpenCPU? Nobody knows OpenCPU. Okay, so I can promise that you will leave this short session with some basic knowledge of OpenCPU that you can put it to work right away. But before we start, let's talk a little bit about predictive analytics. So, this is actually a true story. Target, the store that didn't succeed in Canada, had a story back in the US, which actually broke news of when they sent to the home of a teenage girl a welcome package to their pregnancy program. And the girl's father opened the package and was very disappointed. And he went to them and they said, "My daughter is not pregnant." And they said, "Sorry, sir, but our system said she is." So they basically used their loyalty program. They checked the purchasing habits and what items she's buying, and they concluded that most probably this girl is pregnant. Now, there is debate in the field whether this is actually a true story or not. Like Target says it was misunderstood, some others say it was all like a media hoax, but at least it shows the power of predictive analytics. So what do we mean by predictive analytics? And before we go there, I want to ask you a question. Who knows who won the highest prize in Jeopardy, the TV show's history? Watson. IBM Watson actually won the prize. And Watson is the perfect example of predictive analytics, because what it does, it was fed structured and unstructured information from many, many sources, including the web, though during the show it was disconnected from the internet. So it had to rely on the information and data that it had. And whenever a question was asked, so Watson had to go through all this possible answer to this question, use predictive analytics techniques to figure out which is the best match, and basically raise its hand and give the answer. And it won against the two champions of the program who made the most money and were most successful in the history of the program. So, before we define predictive analytics, it makes sense to first define analytics. This is from Wikipedia. So it basically says, analytics is the discovery, interpretation, and communication of meaningful patterns in data, especially valuable in areas rich with recorded information. Analytics relies on the simultaneous application of statistics, computer programming, and operations research to quantify performance. Analytics often favors data visualization to communicate insight. So that's basically us using our computing knowledge, our programming knowledge, our database knowledge to look into existing data and try to find trends and explain what happened. So that's what we mean by analytics. By predictive analytics, the key here is that we use techniques like predictive modeling, machine learning, and data mining to analyze current and historic trends. The key here is to make predictions about the future. So if we go back to the story of Target, that's actually Target looking at their point of sale data and customer data and realizing that, oh, this girl is most likely pregnant. Or Watson looking at this structured and unstructured data warehouse and saying, this is the most likely answer to this specific question. Okay, so we predict. The key about predictive analytics is that we are looking into the future. We're trying to expect things that may happen in the future. In business, predictive models exploit patterns found in historical transactional data to identify risk and opportunities. I assure you that each of you have used predictive analytics in one way or another during this morning. Who checked the weather? That's predictive analytics. So they actually use weather modeling to predict what will happen. Will it rain? Will it be sunny? Whatever it is. Who used Google Maps to find their way today? Google Maps used analytics to say, oh, that route is going to be busy, that route is faster, that route is better. So we basically use it every single time, and most likely more than once, every single day. So I just put together a short comparison between analytics and predictive analytics. So as I say, analytics is actually looking into the past, trying to explain what happened. Predictive analytics is trying to look into the future and predict what will happen in the future. Analytics is good for observing trends, while predictive analytics is good for making decisions about how should we act in response to possible future events. It's really important to understand the difference because people use the terms interchangeably and they are not. Okay? Any piece of software or website or platform that you see that has reporting capabilities, these reporting capabilities are basically analytics. Okay? Sometimes they are called business intelligence, where you can actually change the views of the tables or the reports you get, or how the data is displayed, or how the graphs are displayed. But the key here is that only reporting on what happened. They are not looking into the future. And the key that differentiates between looking at what happened and projecting to the future is using predictive models, mathematical models that could explain what might happen. Of course, they are not perfect. No one can exactly tell you what will happen tomorrow. But as our reliance on weather forecasts, traffic routing, we have pretty good confidence in these models. And that's what differentiates the analytics, which actually use the past, use facts, things that actually happened. I can be 100% sure that it was raining yesterday, but I cannot be 100% sure that it will rain tomorrow. I can be 80% sure. So that's the key difference between both things. Gartner, the consulting firm, put together a very nice scale of analytics maturity. So they start from descriptive analytics, which actually help you explain what happened in the past, whatever events that has happened in the past, and then diagnostic analytics that go beyond describing the events and trying to explain why these events happened, and predictive analytics, where we stand today. Our subject of today's talk is what will happen in the future, and there is now an emerging field, completely new, a couple of years old, that's prescriptive analytics, that will tell you how can we make this future happen. So over the years, we moved from looking at the data that we are collecting, first using pen and paper, then using computer and databases, then looking at this data in the aggregate and dicing and slicing it in different ways to uncover trends and understand why did these events happen. And today we're using our understanding and the technologies that we have to predict what will happen in the future. And just as we speak, there are many smart people working on ways that will help us create the desired future events using prescriptive analytics. And this is nice. So it says you see the difficulty increasing from just looking into the data that you have in your databases to structuring it in a way that exposes trends, to predicting what will happen in the future, to actually working on creating the event that you want to create in the future. So this thing isn't actually new. Predictive analytics, or the whole analytics field, isn't actually new. But it was easy here because it's basically queries into the database. You just look at the database and say, give me how much money the specific customer spent over these 3 months. That's simple. Or what happened in the weather. Diagnostic is actually aggregating the data, coming up with all nice ways of organizing it to see, trying to explain what happened. So the principles are there. And predictive analytics, just like we had weather forecasts for many, many years now, it actually depends on mathematical models. Some of them are very simple, linear regression. Some of them are very, very complex, like the ones used by Watson. But the key here is, why are we hearing predictive analytics more and more in the media, in research, in science? Because now we have two things. First of all, we have enough data, this whole big data thing, that we can actually help train our models, mathematical models, so that their outcome makes sense. Secondly, we have enough processing power and computing power to process all of this data, these huge amounts of data, and use it to train our models. Then our models make sense. And that's why now we will see more and more move towards predictive and, in the future, prescriptive analytics. So, as I told you, the easiest example of predictive analytics has been around us for many years is the weather forecast. It tells you what will happen today, tonight, Saturday, Sunday, probably 10 days into the future, based on mathematical weather models. So, and sometimes they use the term model on TV when they say our models show us this will happen, this is what will happen. Okay? Traffic routes, same thing. Whenever you see them saying, oh, it's gonna be busy here or that, that's not right now. It will happen when you reach there. Okay? And that's also based on mathematical modeling and predictions. This is very interesting because this morning I was actually trying to book my flight to the Web Summit in Lisbon next week, and Kayak said, advice watch. So I clicked on this, and they said prices will likely fall within 7 days. Our model strongly indicates that fares will fall during the next 7 days. This forecast is based on analysis of historical price changes and is not a guarantee of future results. But that's amazing. It's actually a very smart, innovative application of predictive analytics. Kayak knows because they have all this data of the bookings and prices and changes for the past 10, 20 years. And they can know that for this specific trip, the price will most likely, and you see they have trends, you can actually explore it, it's really cool. And that's what actually led me to this whole open CPU area. So what we wanted to do is to have this is happening in real time, because it relates to my own trip, the trip that I'm actually booking right now, okay? So what happened is, somehow, Kayak sent this trip information to some mathematical prediction model somewhere, got the advice, and showed it to me, okay? In a very nice, easy to use part of their website, within the web application. And that's what we were interested in. So I will talk to you now about a very nice open source tool for predictive analytics, and how we can use OpenCPU to expose these capabilities as in web applications through the web. Also, one very famous application is the personalization and recommendations you get in sites like Netflix, like Amazon when you buy books, because these are also predictive analytics models. So they analyze your profile, and they suggest movies based on your own many parameters, but including your demographics, what you like, what your friends like, what people like you like, what people who like this film also like, all these kinds of things. And do you know the story of the Netflix contest that happened a few years ago? So Netflix said, we want, like, the key for us to succeed is to personalize and give relevant and reliable recommendations for our viewers, right? The more relevant these things are, the more I will stick with Netflix and not go to their competitors. So they did something quite innovative. They say, okay, what we will do is, we will put all of our recommendation data on the web and ask for people to contribute improvements to our recommendation algorithm. And anyone who actually succeeds in improving the recommendations by 10% will get $1 million. So they put the data. There's a very nice website called Kaggle, Kaggle.com. So it specializes in machine learning and predictive analytics contests. They put the data in there. It's still available if you want to see it. And they opened the competition. And teams started to form all over the world, trying to beat Netflix's own algorithm. And the team that won were actually two guys from Montreal who had no idea what analytics or machine learning was. And they were actually, seriously, they were learning as they developed through the contest, which it makes sense, because sometimes all what you need is this fresh, external, outside perspective to uncover something that those who are so focused on the system couldn't see. So that brings us to open source analytics. There's a fantastic project called R that's open source, more than 20 years old. It's basically a statistical analysis package. So you install R and you get all of these kinds of things, mean, standard deviation, logarithmic regression, all kinds you think of. And because it's really old and mature, so it developed a very nice ecosystem around it. So many people actually contribute plugins, libraries, almost everything you want in statistics and math is available in R. And our story is, when we're building one of our solutions, so we needed to predict for physical stores how much the customer will spend over his lifetime. We call that customer lifetime value. So how can you actually predict the customer lifetime value for each customer? And how can you predict what we call the churn risk, which means how likely it is that this specific customer will walk away and never come back for whatever reason. Bad customer service, high prices, better competition, whatever it is. Which led us to use R, because we want to use open source technology, don't want to go to the commercial alternatives. And the idea is pretty simple. So you need to get some historic data about whatever you want to do, like recommendation, you want to predict customer lifetime value, you want to predict congestion, you want to actually predict students' results. You need historic data. You split this data into training data and evaluation data or testing data. And you start trying with models, all kinds of mathematical models, from the simplest to the most sophisticated. And there's plenty and plenty of resources that can help you around the R community. So every time you build a model, you train it with the training data that you dedicated for training. You test it with the test data. If the outcomes make sense, so it means that the model you created has good prediction power. So it can predict with like 80% accuracy, 90% accuracy, until you're satisfied. You say, okay, I can live with 80%. I can live with 95%. So at some point, the output of your work is this predictive model. okay, that you tested, evaluated, and you're sure that it makes sense and will provide value to customers. I'm sure that's exactly what Kayak did when they built their model for pricing that says, okay, wait, because prices will likely go down. So they have some kind of score of how likely the price will go up or down or stay the same. And we built these models, and it's nice. You can use them on R, you can have it on your laptop or your server, whatever you want. But then the problem becomes, how can I expose this predictive functionality to the web? If I want to use this in exactly the same way like Kayak did it when I was checking for my ticket. So how can I use that same R model that I have confidence in through a web interface? And that's precisely where OpenCPU kicks in. So it's kind of a larger system, but for our purposes, let's just focus on its relationship to R, because that's the predictive part. So it uses an HTTP API to expose R scripts, functions, and models, which means that I have my model, I'm happy with its predictions. Now I can put it behind OpenCPU, and I communicate with OpenCPU through an HTTP API. Okay, so OpenCPU will take that request, execute it in R, and return the results back to me in real time. So I can also use it for, R has some very sophisticated graphics capabilities, showing very sophisticated graphs and analytics. You can use it, you can use OpenCPU also. So I'll show you some examples now to embed these graphs in websites, in web applications, or even any other application that can communicate through a REST API. Okay, exactly. So any software program that speaks HTTP can call R functions through OpenCPU without needing to know what R is, without having to go into deep, implementation details or understanding the syntax for the R system. And OpenCPU will provide all the management of requests, load balancing, caching, security, credentialing. All of that will happen through the OpenCPU interface. So in the end, what do I get? I get exposure of my predictive model capabilities through an open web-based API, which will enable me to build scalable, production quality software. And since it's based on HTTP, I can certainly use cache control, SSL, load balancing, anything that you can use with HTTP, okay, like normal web applications. So it does all of that through what they call OpenCPU apps. And an OpenCPU app is actually a small package that contains your R script with some additional, like quite few and simple web resources, so that they expose these functionalities to the web. Okay. And there's a library called OpenCPU.js that will enable you to really build your application very quickly. So you have your model, and I will show you now the structure of a complete OpenCPU app. You have the R model that you build, the R script, and then you can use OpenCPU.js to embed these features, functionalities in your web page that you want to interact with. It depends on jQuery. Not required, but it's very easy and convenient to use. So how do I actually make use of OpenCPU? How can I use it? There are two implementations. One we call standalone, single-use server. It doesn't have the sophisticated caching, credentials, security management. You can actually use it for testing purposes, development environments. The other version is the cloud server, which is the production ready release actually, and it requires Ubuntu 14.00 or higher. So, are we happy with the components of the OpenCPU applications? Okay, so we have an R model called RScript that I can usually communicate with through RStudio, and I want to take this and put it on the web so that I can interact with it using JSON and HTTP APIs. Okay, I didn't actually. It's very easy, very straightforward to install on a fresh Ubuntu setup. Very easy, but I was afraid that the internet might not work, so I set it up already. We'll get to it now. But it's really, you just go to the repository of OpenCPU, you just update the apt-get, and then you install OpenCPU. That's simple. So I can actually go to our test here. So this is actually our instance on sorry. This is our instance on AWS, and as you can see, so you have the Explorer. You can choose the method. You have get, post, options. Okay. So, and that's the endpoint, the web services endpoint that I want to communicate with. So I can actually, this one is telling him, show me what do you have in the library, get request to the library. So I say Ajax, so it will show me now HTTP 200 OK, so it just returned the valid HTTP response, and it's showing me all the libraries that I can access. These are part of the standard R installation. So you can see everything, graphics, markdown, matrix, lots of cool stuff. So let's go back to this now. Fairly basic stuff. How can I start? I can start, stop OpenCPU as a service. Restart like any other Ubuntu or Linux service. And the other part, we said that the production version, this cloud server, has caching capabilities. And it's really important. I cannot stress this enough, because predictive analytics models are complex. And they take a long time. You will see now when we send some requests to the server, they take a few seconds. Sometimes even up to a couple of minutes, 3 minutes, depending on the complexity. So by enabling the caching server for OpenCPU, every time I'm sending the exact same request, it doesn't have to be processed all over again. Huge improvement in performance. So I always recommend doing the caching. Okay, so that's a little bit about the caching server. Okay, now comes the fun part. In exactly like R, which developed an ecosystem of libraries and applications and scripts, OpenCPU is also developing. It's still not huge like the other open source projects, but it is really growing. So there are some libraries and programs that you can just install very easily. So to install the tools is very easy. So you can just say, if I want to get it from GitHub, if I have a library on GitHub, I can say install GitHub gitstats, that's one of the libraries available, and the username OpenCPU. So I can probably connect to the server now. Okay. So if I go and say R, so that's usually the interactive R console. Usually that's where I send the data for my predictive models, and it will give me back the results. And when I build my model and I do the training and I do the testing, I use this interactive platform. On Windows, you can use something called RStudio, which helps you, it's like an IDE for R. But when you finish, you package your solution and you put it on the web. So I actually installed these, but let's just try again. Should have dev tools. I can just say library. Okay, so now we built the dev tools library. I can say install git stats. So it should fund it now, but let's see. So I installed it already just because I didn't want to mess up during this. Alright, so I can now go to my same server. So let me first show you what it will show me if I say, so if I say open OCPU, I will get this Explorer option, okay? So if I say library, and the library is actually a package of different scripts or tools that you can use in R. So it should give me a list, the same one that we saw when we sent the request in the previous page. So let me now go and say, what is it? Git stats. Okay. So that's the information on the Git stats package. It says Git stats, application, release date, all the information that we have. But let's now go to the web app for Git stats. So look what it did now. It actually went to a user organization name, pulled their GitHub profile, and showed me all of their contributions and stars. So all of these graphs are built using R. It's the easiest way to embed sophisticated, advanced graphics in a web page. So everything here is just normal web request. Any of you is a contributor to GitHub? Do you have a GitHub repo? Anyone? Name?
A-Volcom. A-V-O-K-O-V.
I can't take any.
Sorry, A-V-O-L-K-O-V.
A-V-O-L?
Yeah, K-O-V.
K-O-V. V. Isn't this you?
Yeah.
So what happened now, our server that we just started communicated with GitHub with your username, got all of your commits, fork stars, and everything. I'm not sure if it's interactive. Let's see. It's not. Because what you can do, actually, you can make it interactive and get more. You can probably also export this as PDF. You see? Very easy. So have a PDF, very little effort, lots of output. So I put here just a little bit of how you can install an R library. So anything that you install on the R installation on OpenCPU would immediately be accessible through the OpenCPU web interface. Okay? So to install from source code, you just get the library wherever it is, and you just install it. Or my preferred way of doing it is to have an interactive R session like the one I did right now, where I said library so and so or install or anything. So I will just there's another one. So this one is called TV Score. So it's actually a predictive analytics model that predicts how many hours people would, on average, watch TV based on their age and marital status. Okay? So it's an OpenCPU contribution, so it's available on GitHub. So let's first go to the GitHub page of that project. So this is the project for DB-Score from OpenCPU. And as you can see, we have the R stuff. That's the model that you built. Okay? This is the data that you use. But there is, that's how you use all the documentation and everything. So I actually installed the model. So I can just go to here. And I say OpenCPU library DB-Score www. So here it is. Now it's showing me a graph of, this is the age, this is the average average hours of TV per day. And different colors are for married, widowed, divorced, so on. So that's fine, but it gets nicer when I actually start asking it to give me actual predictions. So I will connect to, so here I have a JSON object that says I have 3 individuals, 26 years old, married, 41 divorced, and 53 never married. Okay? So I can just send this JSON object to the Web API endpoint for DB-Score, and you will see now. Okay. Sorry, that's not it. So that's what it did. So it predicted how many hours of TV each of these individuals will watch. So the 26-year-old will spend 2.95, 41-year-old 2.61, 3.10. So now, because that's so simple and straightforward, you can take this data and plug it into any web application that you're using and really unlock the power of whatever predictive model that you build. So another one that I actually wanted to show you is there is a basic function in R that says, it's called rnorm, which means just give me normal numbers, generate normal numbers, okay? So I can very simply go to that endpoint and say, give me 2 normal numbers, sorry, random numbers, give. But I can also say, mean is 10, and standard deviation is 4. And let's have 5 values. So these are 5 values, random values, where their mean is 10, and their standard deviation is 4. So can you see how this can be useful for you? Just imagine any mathematical function you can think of, you can easily access it through a web interface. For me, that was a very important turning point in our application, because now we can not only do like batch processing and update the record in the database on a nightly basis, we can actually show it to the user in real time. It's much easier. So we did the CPU score. Okay, so now just a couple of slides that will help you. If you want, I can share these with you. If you want to use it, give it a try. So it's actually the how do you configure the server, the OpenCPU server. If you want to, like, what packages you want to preload for performance, what's the size of the file, because sometimes you create some very large files. Let's say graphs, like you have some big graph of student performance over the years or whatever. So these become very difficult to send through the web interface in the browser. So usually what happens R will create a file in a temporary folder, and you access that file, and you get that information from that folder. Maximum memory, so you see default is 2 GB because some models are very simple, like logarithmic regression or linear regression. These are easy, but some models are very complex. So for example, the models that Watson uses, it uses a wide variety of models, different models, almost about 1,000. So it sends the exact same request to each of these models, and then it calculates a vote. Like how many models came up with this result, this, and then they choose the best one. That's a very big performance issue. So that's why we usually say, try to give it enough, like memory, give it sufficient time limit for the request, and use caching. Caching is really important in these cases. So that's how we get through curl. We can do this, and we tried R. Okay, so try one of these. Okay, so thank you very much. This is all that I have. I hope it was helpful, and if you have any questions, please feel free to ask.
How complicated are the R models that you're using? Like, is there source or something, or are they just compiled as binary?
No, they are all source code. They are all in source. So they use the R language. So they call them R script. I will show you the one for the TV score. So if you go here, in this folder. So these are the models. So I actually have R. We can actually have a look at this. Oh, here it is. So here it is. That's simple. The outcome is actually very simple and straightforward. The difficulty is finding the right model for your problem. And to do so, the way you have to do it is first to start by organizing your data properly and splitting it. Usually we do 70% of the data we have as training and 30% as test. And then trying every single model you can think of. Some models are more suitable for specific problems, like predicting, for example, possibilities, like will this patient have cancer or not? So that's a binary outcome. Others are better for scale predictions, like the average age of males in Toronto, for example, 90 years, 91 years. It depends, but you develop this over time. It's really fun, like working with R, but when you finish, it's really a very simple model. And all of these are available. I can actually go and show you a little bit of the stuff that you can play with. So if we go to the example, that takes us to opencpu.org. So you have stuff about stocks, get stats, we tested it, PD score, we tested it. I don't know what this thing is. So you can just check a demo, they have it all set up. Demonstrate the use of opencpu.js. That's the whole purpose of this. So all of these are available within the R script language. It's very, very straightforward. We have another question.
What kind of security factor there? Because it looked like, at least on the box you're using, there's no authentication, and it'd be trivial for me to put on GitHub and tell you to install it, and then I just
no, because okay. So first of all, we didn't implement any authentication on the OpenCPU server, just for the simplicity of the demonstration, that's all. But you can actually have authentication with cookies, username, passwords, private public key. You have all of these options, number one. Number two, I don't think, though don't take me on this, but I don't think you can actually own the OpenCPU server through the code you have here, because it's very contained. So what it's expecting is some very specific stuff. And it's contained. I'm not sure, I haven't got that far, but I think it's expecting R scripts, a very specific way of putting the web page that will display. So, but I'm not sure. Yeah. We need to check into this.
So do you need to know statistics, for example? Because the thing is, you're saying that you need to data for for creating a model and then for evaluating the model. Now, if you have no background in mathematical modeling, then it's kind of something else altogether.
Yes, it's. I think it's going to be very important, and for us in the college, like what students are learning as part of their computer science courses, I think we should seriously push for statistics, because the hottest job for the next 5 years in the tech sector is data scientist. And data scientist is someone who understands statistics and can actually dance with these kinds of models and analytics. But yeah, absolutely, statistics is very important. Like just the fact to understand what the meaning of accuracy means needs statistical background. You wouldn't know what's the difference between all these kinds of things are standard deviation, averages, models.
And then the other question I have is, now you've given, for example, let's say that you gave the thing of TV ads. So what I'm thinking is, let's say there was a business that was going to make some business economic decisions based on the model, predictive model. I mean, if the model itself can be flawed, right? Like, I mean, that's, and then, for example, let's say that the thing of kayak you showed, where the statistics show that the price is going to fall, but that may not necessarily.
Yeah, in the end.
Because there's one thing of prediction, and then there is the certainty of the prediction. Right?
Yes, in the end, it's like the weather. It's the weather forecast. They say there's 70% chance of it raining. It doesn't mean it's going to rain, but it most probably will rain. So it's this balance. Now the business has an edge because they can actually measure it. Like these percentages translate into revenue. And if I, for example, if I listen to Kayak's recommendation 5 times in a row and they get it wrong, like I'm not gonna listen to them anymore. So they wouldn't deploy a model unless they believe it actually gives value. So if I listen to it once or twice and it works, nice, they save me a couple $100. So that's in the end, it's not an exact, like 100% science. It's art and science and statistics together. So you need to really be happy with probabilities of 70, 80, 90% of the prediction being correct, but not 100%. It's impossible to be even 99% sure. And that's where actually the whole work in predictive analytics is. It's actually tuning and fine-tuning and training the models again and again, so that, and that's why it's really fantastic. If you guys have probably some time to still studying, go to Kaggle, because you can make good money if you win. I think now there's Santander, the bank, they have a competition about credit card or something. Because what I like about this is that you see the different ways of solving the problem, but most importantly, they have fantastic data sets, like real time, donated by real companies. So
also, this is reliable data sets.
Exactly. This is data sets that are donated by companies.
But if you use the data sets, then do you have to pay them?
No. Absolutely not.
Because you actually get the model right, you need an accurate data set, so you don't
Exactly.
give you the best
Exactly.
accurate data.
So this is, for example, data about U.S. presidential election. Yeah. They're being so just 30,000 memes.
All right. So
And it's been uploaded for 233 times. So people are working on this. So you can see all of the memes. Yeah, they have their tool called kernels where you can check it. It's super cool. You can spend nights and nights just exploring what you have around this. But the competitions are very nice because so this is the one. This is Santander. This is a bank in Spain, Santander. So can you pair products with people? So they give you the data, that's real data, real bank data. You don't have access to this usually. It's anonymized, of course. So they have, it ends in 21st of December. Where's this here? So you see they have training, test, and now you should submit 214 megabytes. Yeah. Plenty of cool stuff to work on.
I just wanted to, I don't have questions, but I wanted to add to it. Says my brother, he worked on a site similar to Kaggle, and he's not a programmer himself, he knows some web stuff, but he ended up working with R and using the stuff that you showed here, not OpenCV specifically, but R and RStudio. And he actually won, like he came third place on one of the competitions and won like $1,000. So I'm just gonna recommend it's worth it if you're interested in doing something, because you can actually win a lot of money.
And if you're looking for a job, just think of the difference it means when you say I won this on Kaggle, even like 10th place, whatever. Like for me, this means you worked with real data and you created real models. So that's exactly what I want. So this is a place where people should really spend time with, and it's also fun. You can play with the memes. You see what people are. Yes, the 3,000 memes. Okay. So thank you very much for your time. Anything, just